Hello everyone, I'm Mr. Fatur here. For this video, we are going to talk about prime factorization. Okay, first of all, you have to understand what the concept, the meaning of prime factorization. What are basically prime numbers? Okay, prime numbers are basically numbers that only have two factors, one and the number itself. Basically, in short, prime numbers are numbers that cannot be divided by any number except for one and itself lah. Okay, so those lonely numbers are like number 5, 7, 13, 37. All these numbers you don't cannot divide by any other number except for one and itself, right? So all these are what we call prime numbers. Composite numbers are the opposite of prime numbers. Any number that can be divided by other numbers. For example, 10. 10 is a composite number. Why? Because 10 can be divided by 5, can divide by 2, and all that, right? Now, apart from dividing by itself and 1, 20 is a composite number. Why? Because 20 can divide by 2, can divide by 4, can divide by 5, can divide by 10, so on and so forth, right? Is 11 a composite number? No. 11 is a prime number. Why? Because 11 can divide by only 1 and itself. That's all. It cannot be divided by any number. Okay? So that's what we call prime numbers. Okay? So now, let's talk about the main cause of this topic, prime factors. What are prime factors? Remember back in primary 4, you learn factors, right? What is a factor of 24? Then you ask yourself, what times what equals to 24? 1 times 24, 2 times 12, 3 times 8, 4 times 6, see? Right? You have to think of all your timetable, right? In this case, they will teach you the easiest way to do your prime factors, to do your factors of 24. Okay? So for example, prime factors are basically the simplified version of all the multiples that could add up to 40. All the multiples that could make up to 40. Alright? So when they ask you to express 40 as a product of its prime factor, you have to express it in a ladder method. Some of you right may have learned this. They call it the pyramid or the binary method. Don't have to do that lah. Alright? Just be more straightforward, just use the ladder method. So when it comes to the ladder method, so for example, you have 40, right? Prime factorization of 40. You always must start off with the smallest. See this? Smallest prime number. Always start from the smallest prime number. Okay? Start with the smallest prime number. So for 40, divide by 2, you get 2, right? Then divide by 2 again, you get 10. So you keep on dividing by the prime numbers until you cannot divide anymore. Then you move on to the next prime number. And then you continue again until your final answer becomes 1. Okay? So once you divide already, right? You see you got 2 and 2 and 2 followed by 5, right? So you then realize that this part over here, you have 1, 2, 3. Three of these number twos. So all the numbers in the ladder, you go and multiply. You must write out in form of multiplication. 2 times 2 times 2 times 5. You must write out. So once you have already written out, right, you realize that there are 3 of these twos together, right? You must put the power. So it becomes 2 to the power of 3 and then you times 5. Alright? So that's how you express as a product of each prime factor. Okay, so another example. Okay, let's try this for yourself first. So 56. How do you express 56 as a product of its prime factors? So you have 56 here. You divide by 2. You get 28. Always start with the smallest prime number. Don't jumble up all these numbers because the moment you jumble up, right, later you will get very disorganized. Later all the numbers are you salah already, all wrong already. Okay? So 56 divided by 2, 28. You can still divide by 2. So I divide by 2 again, I get 14. Divide by 2 again, I get 7. Now 7 cannot divide by 2. So what's the next prime number that can be divided by 7? Which is 7. Then I get answer as 1, right? So now I have 2 times 2 times 2 times 7. So how many 2's are there? 3. So I get 2 to the power of 3 times 7. That's how I do it. Okay? Now 72. So 72, same thing as well. Divide by 2, I get 36. divide by 2 again, I get 18. Divide by 2 again, I get 9. Now, can I divide by 2 further? Cannot, right? Move to the next prime number. I can now divide by 3. I get 3. Then I divide by 3 again, I get 1. So now it becomes 2 times 2 times 2 times 3 times 3. So how many 2's are there? 3. So 2 to the power of 3 times 3 to the power of 2. Okay? So now 100 once again. So same thing, 100 divide by 2, you get 50. Divide by 2, 25. Divide by 2. Cannot 25 divided by 2, right? So the next prime number that can be divided by 25 will be 5. So I get 5. Divide by 5 again, I get 1. So I get 2 times 2 times 5 times 5. So which means 2 to the power of 2 times 5 power of 2. Okay? All these things are must know. If you don't know, that's it. Free marks all gone. Very easy. Just write out only. That's all. Right? Okay. So, next part. Once you have written down the product of its prime factor, that is the most basic thing you need to know. Okay. So what you need to know now are the main other concepts that you must have, which is to find out the highest common factor, the lowest common multiple, and then perfect square, perfect cube. That's all. Just 4 things you need to know. Highest common factor, lowest common multiple, perfect square, perfect cube. That's all. Okay. So for highest common factor, there are 2 steps. Okay. 2 steps. Let's say they ask you the highest common factor of 2 numbers. For example, 12 and 30. How to find the highest common factor of 12 and 30. Back in primary school, you write out all the factors, right? Which is very, very mafan. A lot of things to do, right? So basically right now, to have highest common factor, you just have to follow 2 simple steps. First step, express all the numbers as a product of its prime factors. Both numbers. If they give you highest common factor of 3 numbers, write out all 3 numbers. If they ask you to express the highest common factor of 5 numbers, write out all the 5 numbers. Okay? So write out the all numbers as a product of their prime factors. Then after that, okay, this one very important. You just have to circle the common number with the lowest or equal power. 2 things, common numbers with the lowest or equal power. So let's use an example. Highest common factor of 100 and 150. What's the first step? Express all numbers as a product of its prime factor, right? So both numbers 100 and 50, express them as a product of their prime factors. So 100, same thing as well. Use your ladder method. You'll have 2 to the power of 2 times 5 to the power of 2. So you get this part, right? This one, right? The same thing goes for 150. I get 2 times 3 times 5 to the power of 2. So I get 2 times 3 times 5 to the power of 2. Okay? So, step 2. Circle the common numbers with the lower power. So now you compare this one and this one. Which one is the common number here? Common numbers are not common power. Common numbers. I'm talking about 2 followed by 5. I see 2 and 5 as a common number, right? Is 3 a common number? No, so you don't circle 3. Okay, common number means what? The number must appear in both the numbers, both the 100 and 150. But 3 is not, right? So the only common numbers are 2 and 5. So I got 2 and 5, So I circle the 2 and 5. So next part is circle the lower or equal power. So the common numbers with lower or equal power. Common numbers with lower or equal power. So the common numbers 2 and 5. But in these 2, I circle the common number 2 with the lower power or equal power. So 2 and 5 square. So I get 2 plus 5 square. 2 times 5 square, you get 50. That's all. Okay. So that's how you do highest common factor. Now let's try another example. More examples you try, the better you'll get. Okay. Let's try more numbers. So highest common factor of 100, 200, and 150. Same thing, step 1. Express both numbers, express all numbers as the product of their prime factors. So you get 100, 150, 200, use your ladder method. 100, you have 2 power 2 times 5 power 2. Then you have 150, 2 times 3 times 5 power 2. 200, you get 2 cubed, 2 power 3 times 5 power 2, right? So first of all, where's the common number? Circle the common number. So which one are the common numbers? I see 2, 2, 2. I see 5, 5, and 5. Is 3 a common number? No, so don't take. Okay, so only 2 and 5, right? But take the lower or equals power. So look at the number 2. Which one is the lowest power? Lowest, lowest. Of course, this part lah, because here got no power, right? So highest common factor will be 2 without the power. How about the 5? Realize not? You realize all the powers are the same? So never mind, just take the equal power. Remember, common number with lower or equal power. So you get 2 times 5 squared. Then you get 50. You just have to calculate. Use your calculator. That's how you do your highest common factor. Straightforward, right? Now, you go and give any two random numbers or you go and try yourself. Don't know, come find me. I'll be here in the library. Okay? So now, next part. Lowest common multiple. This is the complete opposite of highest common factor. Remember, highest common factor, you got two steps, right? First step, express all products at their express all numbers as a product of their prime factors, which is the same as the lowest common multiple. The second step, instead of taking, look at highest common factor, instead of taking the common numbers only, right now you take all the numbers available. But when the numbers are the same, for the common numbers, you take the higher or equal power. That's all. Okay, take the higher or equal power. Highest common factor, lower or equal power. Lowest common multiple, higher or equal power. It's terbalik, the other way, opposite. Okay, so now let's try. Remember, lowest common multiple means higher or equal power. All right, the first step is always simple. Express all numbers as a product of their prime factors first. Okay, so lowest common multiple of 24 and 56. 24, 10, 56, done. So now 24 is equal to 2 cubed times 3. 56 is 2 cubed times 7. So what's the step 2? Take all the numbers. Take all the numbers. So look at 24 and 56. Look at their product of its prime factors. What are the numbers that you see? All the numbers. All the numbers. I see number 2. I see number 3. I see number 7. You don't repeat the 2 because I know 2 has repeated, right? You don't repeat. You just take the number only. The power later. The power put later. Okay? So basically, I have number 2. I have number 3. I have number 7. Correct? First of all, list out all the numbers. List out first. Then look at the common numbers. So where's the common number? Number 2 is the common one, right? Number 2 is a common one. Now you go and ask yourself, higher or equal power? Take the higher or equal power. Look at the number 2. The powers are equal, right? So you just write out the power. That's all. If the power is higher, take the higher power. Then the 3 and the 7, there's no power, right? Never mind, doesn't matter. Then from there, can tabulate. Okay? From there, can tabulate. If they never ask you to tabulate, if they didn't ask you to tabulate, then don't need. You can just write your answer as a product of its prime factors. That's all. Okay? Let's try another example. Now let's try another example. Will be on the next slide. Oh, not yet. Okay. How about what if I were to give you an example? So the example will be. Okay, wait, Okay, how about the lowest common multiple of 50 and let's say 70? 50 and 70. Let's try this. So you have 50 and 70. So step 1, express both numbers as a product of its prime factors, right? So you have 50 as a product of its prime factor, divide by 2, 25, divide by 5, you get 5, divide by 5, 1. So then 70, divide by 2, you get 35, divide by 5. You get 7, 7, you get 1. Okay. So now, 50 equals to 2 times 5 to the power of 2. 70 equals to 2 times 5 times 7. Okay. So 2 times 5 times 7. So now, how to find the lowest common multiple? First of all, list out all the numbers available. What are the numbers you see? I see number 2. I see number 5. I see number 7. So I put 2, 5, and 7. Make sure you list out first. List out first. Don't care about the power first. List out all the numbers first. Then now you analyze the power. If the numbers are the same, take the higher or equal power. If the numbers are the same, which numbers are the same? Number 2 here, right? Do they have an equal power? If there's no power, means you don't have to put anything. Okay? Means default is a power of 1. That's all. Okay, so this number 2 has no power, right? Okay, swan. Move on to the next number. Look at the number 5. The next common number is 5. Which one has a higher power? The power of 2, right? You just list out the power of 2. And then this 7, nothing much. That's all. There you go. That's your answer. Simple, right? Another example. Let's try the LCM of 12, 30, and 100. Yeah. And let's say 64. Okay, let's say 64. Okay. So same thing. Now you have three numbers now, right? So what you do is you express the product of prime factors for all numbers. 12 divided by 2, divided by 2, divided by 3, 1. 30 divided by 2, 15 divided by 3, divided by 5, 1. 64 divided by 2, 32 divided by 2, 16 divided by 2, 8 divided by 2, 4 divided by 2, 2 divided by 2, 1. There you go. So now you know 12 equals to 2 to the power of 2 times 3. 30 equals to 2 times 3 times 5. 64 equals to 2 to the power of 1, 2, 3, 4, 5, 6. 6. Okay. So now how to find the lowest common multiple? Sure. Combine all the numbers first, remember? So what are the numbers you see? I see number 2. I see number 3. I see number 5. So I'll put 2, 3, and 5. They're supposed to multiply them together, right? So once you're done with this, now once you take a common number, if the numbers are the same, take the higher or equal power. Now look at the number 2. All same, right? Equal common numbers, right? Which one's the highest power? 6. That's all. Then you look at the number 3. Are the powers the same? Which means no power, right? Never mind. Let it be. Then the 5 also let it be. That's your answer for lowest common multiple. Let's try highest common factor for this. What's the highest common factor for this? Highest common factor, only circle the common number with lower or equal power. So which numbers are common? I'm talking about all three. Cannot just two only. I must have all three. You look at the number 2. The number 2 is a common number, right? For all these three, right? So I put number 2. Where's the lowest power? This one. The one without power. That's all. Do I include number 3? No, I don't include number 3. Why? Because number 3 only appear in these two. It doesn't appear in this 64. It did not appear in this 64, right? You don't bother. Alright? Common number means it must appear in all the numbers of the prime factors. Okay? So the highest common factor is 2. Lowest common multiple is all these numbers combined together. Alright? Okay, now let's move on to the next part. Perfect square. When it comes to perfect square numbers, perfect square means the powers have even numbers. The power is an even number. When I say power, it means what? 3 to the power of 5. So this 3 is the number, 5 is the power. Okay? 3 is the number, 5 is the power. So if you look at this part, you get 2 to the power of 6. It means 2 is the number, 6 is the power, 5 is the number, 2 is the power, 7 is the number, 4 is the power. Okay, so that's what I meant by powers with even numbers, even number powers. All right, so usually the questions will ask you this: express, find the smallest integer k such that 24k is a perfect square. They give you a random number 24. Can be 56, can be 62, can be any number lah. Alright, as long as the number here is a perfect square. So how to know that it is a perfect square? How to make it a perfect square? Follow these 3 templates. Just follow, that's all. Blind person also can follow. Right? So first of all, express 24 as a product of its prime factors. So 24 as a product of its prime factor, you will get 2 to the power 3 times 3, that's all. When there's no power, what's the default? You must put power of 1. That's the default. Okay? Always remember, no power means power of 1. Alright? So now, your next part is to express 24 as a product with prime factor. The same thing, right? But because they tell you 24k, 24 times k. So this means you must add the power. You must add the power such that it becomes an even number because I want perfect square, right? So now 24k becomes what? You look at the 2 power 3. You look at the original power. 24 to the power 3, right? But I need to add a power such that the power becomes even number. So ask yourself, what is the smallest number that is larger than 3 but an even number? What is the smallest even number that is larger than 3? You get 4 what? That's the smallest even number that is larger than 3, right? 4. So I must put 4 here. Okay? How about the next part? This 3 to the power of 1. Is this an even number power? No, right? Because power is just 1. What? So what's the smallest even number that is more than 1? Smallest even number that is more than 1. 2. 2 is the smallest even number that is more than 1, right? There you go. Okay. So here you must top up the power. You must increase the power to make it even number. So to find the value of k, remember the powers that you have already top up, you find the difference in those powers. So you look at this 2 power 3 and this 2 power 4. What's the difference in the power? 1, right? 2 power 3 and 2 power 4. What's the difference in those powers? 1. And then this 3 power of 1. This 3, no power, remember? No power means power of 1. This 3 power of 1 and this 3 power of 2. 3 power 1 and 3 power of 2. What's the difference in the power? 1. There you go. Then you can find out the value of k. Simple. Let's try another example. Okay, smallest integer a such that 20a is a perfect square. Okay, now 20a is a perfect square. Huh? So now in this case, first same thing, 3 steps. 20a. 20a means 20 times a. 20 times a means add the power. Okay, so first of all, express 20 as a product of its prime factors. So 20 equals to 2 power 2 times 5. That's all, 2 power 2 times 5. So no power means power of 1. Always remember, no power means power of 1. Okay, so now next part. Add those powers to make it even number. Now you go and check my current numbers here. Look at the power. Is this an even number? It is an even number, right? So must you add the powers? Don't need, because it's already an even number. What? So don't need to add. So don't need to add means the power becomes the same. Okay? Because already even number already, what? So why should I add? Right? So now let's look at the next number. 5. The power is 1. So must I add? Yes, right? Because 1 is not an even number. What? So what's the smallest even number that is larger than 1? Smallest even number that is larger than 1. Larger than 1. 2. So 5 power 2. So once you get this already, so this is the value of 28. Okay, 28. 28. So how to find the value of A? You find the difference in those powers. So you look at this 2 power 2 and 2 power 2. Did I add any power beforehand? No, right? Because it is already an even number, what? Right? So it becomes 2 power 0. The power 0 because I didn't add any power. How about this 5? Did I add any power? Yes, I did. I did add 1 power over here. I did add 1 power over here. So use your calculator. Go and find out the answer. That's all. Very, very simple. Okay? So now, let's move on to the next part. Perfect cube. Okay, but before we move on to perfect cube, I have one thing that I want to add on. About perfect square, we talk about the product of, we talk about 20A, 20K, 56K, 56B or whatever. It's all multiplied, right? What if they tell you 50 over K is a perfect square? 50 over K is a perfect square. This one, this one will be the opposite of 50K. Alright? Remember the previous concept? We add those powers, right? But right now, 50 over K, 50 over K is a perfect square, right? So 50 over K means you have to take out those powers. I'll give you an example. 50. So first step, same thing. Express 50 as a product of its prime factors. 50 will be 2 times 5 square. Okay? So now if they give you 50 over K, 50 over K means you need to take out the power. Take a power that is smaller now. Smaller, not larger, okay? Take the smaller number. Take a smaller power. Now you go and analyze the product of its prime factors first. 2 power of 1 times 5 power 2. 2 power of 1 and 5 power 2. Which one of these is a perfect square? This 5 power 2 is a perfect square, right? How do you know? Because the powers are even number. So now you look at this 2 power of 1 over here. This 2 to the power of 1, you must take out the power. So perfect square means the power must be even number. When the power is even number, the smallest will be 2. The smallest number that is an even number. Smallest even number is 2. Okay? When the smallest even number is 2, I have the power of 1. So how do I take out? So the smallest will be 0. Why? Because you don't meet the minimum requirements, right? The smallest even number is 2. But right now your current power is 1. It's already smaller than the minimum requirement, right? Over K means I need to take out the power. So end up the power becomes 0. Okay? Then times 5 to the power 2. Why? Because this 5 power 2, I don't need to take out anything because I met the minimum requirement. I've already made sure that my power is an even number. So the value of K will be, what's the value of K? Same thing. Find the difference between both powers. So the 2 power difference is 1, 5 the power difference is 0. And your answer will be 2. Okay? I'll give you another example. How about 75 over B is a perfect square? 75 over B is a perfect square. So now, so in this case, 75 over B is a perfect square, same thing. Express 75 as a product of its prime factors first. 75 is equals to 325 times 5 square. Okay, 3 times 5 square. Okay, so 75 over B. So how do I make it a perfect square? Because look at the powers. So first of all, analyze the powers. So look at 3. Is this a perfect square? No. Why? Because the powers are less than 2. Less than even numbers, right? So what's the number that I could reduce it to? It becomes 0. Because it did not meet the minimum requirement of 2. And then look at the 5. It is already an even number power, right? So don't bother taking anything out. So B will be the difference between both powers. We get 3 power of 1 times 5 power of 0. Get 3. Okay? Let's say I have a number that is having a lot of product of prime factors. For example, I have 60. Okay, no. Let's see, 2, 3 square. 18, 18, 19. I say 90 lah. 90 over k. To be a product, to be a perfect square. 90 over k. How to find the value of k such that 90 over k is a perfect square? Same thing. Express 90 as a product of its prime factor first. You get 2 times 3 square times 5. So now, 90 over k, analyze the powers once again. So this 2 is power of 1 because there's no power. The 5 also power of 1 because there's no power, right? So now, look at the 2. Do they meet the minimum requirement? No, right? So reduce to 0. So how about the 3? The 3 has a power that is an even number. So don't take out anything. The 5 don't meet the minimum requirement. So reduce it down. Push it down. Push it down to 0. So basically K will be the difference in the powers. Okay. What if I give you X value? Let's say a particular number of X equals to 2 to the power of 3 times 5 power of 4 times 7 power of 2 times 11 to the power of 7. Okay. Now this 11 is the power of 7. So if they say x over y is a perfect square, I want x over y to be a perfect square. X is basically these numbers, right? X is basically all these numbers, right? So x over y to be a perfect square. So now same thing as well. Analyze all the numbers. Which number is a perfect square? Which number has powers that are even numbers? The 5 and the 7. You see the powers? Are they even numbers? Yes, they are, right? So which powers are not even numbers? The 2 and the 11. Look at the 2. The power is 3, not even number. Look at the 11. The power is 7, not even number. Alright? So now, reduce it. So this 3, how do I reduce it so that it becomes a even number power? 2 to the power of 2. I reduce it because over what? Over means you reduce the power. Okay? You don't reduce it to 0. Why? Because the minimum requirement is 2. What? So you just reduce it to 2. That's all. Then times 5 to the power of 4 because you don't take out the power because the power is already even number. 7 power of 2, also same thing, don't take out the power. How about this 11? What power? That is smaller than 7 but even number. 6. Right? Because the minimum requirement less than 7 will be 6. Right? Minimum requirement is 2, but the power less than 7, even number power less than 7 will be 6. I want the closest, Okay? Just reduce by 1. So which means y is the difference between both powers. 2 power of 1, 5 power of 0, 7 power of 0, and 11 power of 1. Then you tabulate the answers, 22. Okay? So that's how you do your perfect square numbers, regardless of whether it is multiplied by a letter or divided by a letter. So now perfect cube numbers. Perfect cube numbers. Numbers that have powers which are multiples of 3. Okay? Multiples of 3. Instead of having even number powers, I make sure my powers are multiples of 3. So I have 5 power 3, 2 power 6, 7 power 9. If you look at the powers, they are actually powers of 3, right? Power of 3, power 6. Power of 6 is multiple of 3, what? Power of 9, multiple of 3. Okay? So how to know whether 100, let's say I give you a random number. 1000, is 1000 a perfect cube? How to know? You reduce it to the product of its prime factor. So 1000 as a product of its prime factor will be 2 power 3 times 5 power 3. 2 cube times 5 cube. Look at both powers. Are both powers multiples of 3? Yes, they are. So it means it is a perfect cube. Okay? So now same thing as the perfect square, smallest integer for a perfect cube. So find the smallest integer k such that 90k is a perfect cube. So follow the 3 templates. Express 90 as a product of its prime factors. So whatever number they give you, express it as a product of its prime factor. 90 is equals to 2 power of 1 times 3 power of 3 times 5 to the power of 1. Okay. Now, second step, the smallest added power. You start adding the power. Okay. So go and analyze first. Analyze the prime factors. Look at the 2. Is the power a multiple of 3? No, right? So what's the smallest power that is a multiple of 3? 3. The smallest power more than 1, because the power is 1, right? The smallest power more than the power of 1, which is the multiple of 3. I put 3. That's the smallest one, right? And then I look at the number 3. This number 3, the power is already a multiple of 3. So I don't add anything. And then I look at this 5. The power is 1. How do I make it power of 3? Ta-da! I just add lah. Okay? Because what's the smallest number that is a multiple of 3 more than 1? I put 3. Okay? So 90k will be 2 power 3 times 3 power 3 times 5 power 3. So how to find the value of k? Same thing. The difference between the power. Same thing, the difference. So you look at both powers. You get 2 power of 1 and 2 power of 3. This one. What's the difference in the power? 2. And then this 3, the difference is nothing, 0. This 5, difference is 2. Then you tabulate your answers. Use your calculator, okay? Don't do mental sums. You do mental sums, a lot of careless mistakes will happen. Okay? Same thing. That's all. Last but not least, we are going to talk about over k. If let's say I give you 90 over k is a perfect cube. Now over k means you need to take out the power, right? Find the power smaller than the current power. So what's the minimum requirement for a power to be multiple of 3? 3. The power must be 3. That's the smallest. Anything less than 3 does not meet the requirement. Anything less than 3 is not a multiple of 3, right? Take out the whole thing. Okay? So now 90 is equal to 2 times 3 squared times 5. Hey, this one cannot really. I must use another example. Why? Because all the powers have less than 3 as a power. Right? All the powers have less than 3, what? So cannot. Let's say I give you 250. Okay, 250. Okay, 250. 250 is equals to 2 times 5 to the power of 3. So I want 250 to the power of A to be a perfect cube. So what must I do? I analyze the power. This 2 is power of 1, right? Does this meet the minimum requirement of 3 as the multiple of 3? No, right? So I just put 0. Less than 1. Just put 0. Then times 5 to the power of? Look at the power. Is this a multiple of 3? Yes, it is. So don't do anything about it. So which means A equals to the difference in the power. Ta-da! That's all. Okay? Let's say they give you a larger number lah. 1760. Never mind, lazy lah. Let me give you something. 2 to the power of 6 times 3 to the power of 4 times 5 to the power of 2 times 7 to the power of 1 times 11 to the power of 12. Let's say a number is given. A number's product of its prime factor is given as this, right? If I were to put over B to make it a perfect cube, so what will my powers be there? Same thing as well. No matter how long the product of its prime factors are, right? You just have to analyze the powers. That's all. You want a perfect cube? The powers must be multiple of 3. Anything not multiple of 3, you take out. Okay? So look at this 2. The power is 6. Is it a multiple of 3? Yes, it is. Maintain the power. Look at this 3. Is the power multiple of 3? The power of 4. Is 4 multiple of 3? It's not. So what's the number smaller than 4 and a multiple of 3? What's the closest number to 4 but lesser than 4 but multiple of 3? 3, right? That's the smallest number, what? How about this 5 square? Is it a multiple of 3? No. Did it meet the requirement of 3? Because the smallest number that is a multiple of 3 is 3, right? So this 5, nothing. 0. Put everything 0. Because didn't meet the requirements. How about this 7? Did it meet the requirement? No. 0. How about this 11? The power is 12. Is 12 a multiple of 3? Yes, it is. Right? So which means B equals to difference in the power. 2 to the power 0. Then 3, what's the difference in the power? 1. What's the difference in the power for 5? 2. What's the difference in the power for 7? 1. What's the difference in the power for 11? 0. Then you tabulate your answers. 3 times 25, 25 times 7, 135. Kan? No. 25 times 7 is 175. Right? 25 times 7, 35, 3, 14, 7. Yes, 175. That's your answer. Okay? That's how you do perfect cube. Apart from that, that's all for the whole topic. Simple, right? That's the whole main concept of prime factorization. I hope you all watch this. I hope you all learned something about it. And any questions, just let me know. Okay? Peace out, yo.